All right, lesson 3.6 here on proportional and non-proportional relationships. A relationship is proportional if its equation is of the form y equals kx, k is not equal to 0, and the graph passes through the origin. Some of that stuff should sound very familiar because that's basically exactly what we did for direct variation. Our direct variation equation was y equals kx. We used it a bunch, so that should be very familiar. And we talked about how those always go through the origin. They always pass through the point 0, 0. So far, pretty much the same as that. So an example here is y equals 3x. If we look at the graph, we could see that it goes through the origin. If we look at the table, we can see that and that's what this is about to say right here, if I take my y value and divide it by my x value, so 3 divided by 1 gives me 3. If I do it right here, 6 divided by 2 gives me 3. 9 divided by 3 is 3. 12 divided by 4 is 3. So I'm seeing that constant rate of change, and that would be my k value. That would be my constant of variation. And I can also see in the table that it does go through that point 0, 0. It goes through the origin. All right, so there's a good example. The table shows the perimeter of a square with sides of a given length. We see our table down there about side length in inches, perimeter in inches. Write an equation to describe the relationship. Okay, so let's start by doing what we just did. I'm going to do 4 divided by 1. So 4 divided by 1, I'm going to put up here that that's 4. 8 divided by 2 is also 4. 12 divided by 3, that's 4. 16 divided by 4 is 4. And 20 divided by 5 is 4. So we have a constant rate of change, so that's good. That's the first thing we need. The other thing we want to consider, because right now I don't see 0, 0 on this, so I can't really tell whether or not it goes through the origin. What we can do though, the table doesn't show all the values, all the possible values for this problem or this situation. It only shows some. So what we can do is we can infer from this, we could say, well, what would happen right before those two values, right? So what I'm looking at is in the top row here for the x row, because this is really x and y, I'm seeing 1, 2, 3, 4, 5. Well, what would come before that in that pattern would have to be a 0. 0, 1, 2, 3, 4, 5. It's just adding 1 every time. So I have a 0 in the x row there. How about y's? Right now we have 4, 8, 12, 16, 20. So you're really thinking about what's my common difference, right? Taking it back to 3, 5. Common difference there is 4. You're adding 4 every time. 4 plus 4 is 8. 8 plus 4 is 12, and so on and so forth. So what would have to come before the 4? Well, it would have to be a 0. 0 plus 4 is 4. 4 plus 4 is 8, and the pattern continues. So now I can see 0, 0, that's really referring to the ordered pair 0, 0, or the origin. So now I can be confident in saying that this thing is proportional. It's of the form y equals kx. And from the work we did a little bit earlier, we found that the common difference, ratio actually, is 4. Right? So y equals 4x. That 4 is your k value. It's your rate of change. What conclusion can you make regarding the relationship between the side and the perimeter? So if we go back to that table, we can see that if the side length is 1, the perimeter is 4. If the side length is 2, the perimeter is 8. If you think about that for a second, maybe look at a few more of those. Seems like if you know your side length, you just find your perimeter by multiplying by 4. In other words, the perimeter is 4 times the length of a side. The perimeter is 4 times the length of the side. Good. All right. Moving on. So now this one, we're looking at Marcos's bonus pay. So Marcos is a personal trainer at a gym. In addition to his salary, he receives a bonus for each client that he sees. All right. It says graph the data. We've already provided the graph there for you off to the right. What can you deduce from the pattern about the relationship between the number of clients and the bonus pay? All right, so we're gonna kind of do what we did on the last one. I'm looking at 45 and 1. So 45 divided by 1, that's definitely 45. I see 90 and 2, 90 divided by 2, that's 45. And the pattern's going to continue. Now, you should do all 5 just to be sure. We do want to make sure that this is proportional because they didn't tell us that it is. But it is going to be 45 every time. I'll just save you some time there. And again, we need to check, is this going to go through the origin? So let's go backwards again. My X row, XY, my X row goes 1, 2, 3, 4, 5. So again, before 1 would have to be 0. 0, 1, 2, 3, 4, 5. The bonus pay goes 45, 90, 135, 180, 225. So the common difference there, if you take a second to figure it out, is plus 45. You're adding 45 every time. So if we're going to go backwards from 45, again, we'd have to have 0. 0 plus 45 gets us to 45, and then you continue adding 45. So we do have our origin here on the table. We also, if we look at the graph, if you kind of picture the direction that these points are going, these would hit at the origin as well. It's a little hard to see that because some of those points are sort of hitting in the middle of a couple different lines on the grid there, but you could sort of see it on the graph as well. So what can we deduce from the pattern about the relationship between the number of clients and the bonus pay? Well, it looks like from the table, if he sees 1 client, he gets 45 bucks. 2 clients is 90 bucks. Marcos gets $45 for each client. There we go. Every client he sees, he gets another 45 bucks. Should be able to see that. All right, then write an equation to describe this relationship. Well, we've convinced ourselves that it must be of the form y equals kx because it goes through the origin and because we're finding that there's a constant rate of change. Our constant rate of change we just found was 45. So y equals 45x. And then technically on this one, I'm just going to be a little bit picky. If I'm looking at these axes here, I see a lowercase c and a lowercase b. So technically they want to use those variables instead of x and y. So I'm going to substitute those in instead. C is where x would usually be. So I'm going to put a c where x is, and then b is where y usually is. So b equals 45c. All right, and then part C, use this equation to predict the amount of Marcos's bonus if he sees 8 clients. So we're going to use our equation, that's what they just told us to do, to predict Marcos's bonus if he sees 8 clients. 8 clients, so 8 is a C value. So B equals 45 times 8. And when we multiply 45 times 8, we're going to get 360. So Marcos would get $360 if he sees 8 clients. All right, next one here. This is one that you're going to try. This has to do with a professional soccer team scoring goals and donating money. And it's very similar to the previous one. I think, we probably see Mackenzie Bickle in here somewhere scoring all the goals that she does. So give that one a try, and then we'll move on to here. So this is non-proportional relationships. So already, just based on the name, we should probably be able to think of a few things we know about non-proportional. Mainly, as you see highlighted there, that these do not pass through the origin 0, 0. All right? So, and we're also, if you see here, if the ratio of the value of x to the value of y is different for select ordered pairs that are on the line. So if we try to do our little division that we've been doing on these ones, we're not going to get the same values. So let's see what we mean by that. So they kind of plotted off some points here for us. There's the points they've given us. We're going to put those into our table here. So I'm seeing 1, 9, right? This is 1, 9 right there. And then I'm seeing 2, 12, 3, 15, and 4, 18. Those are the points that I have on the graph right now. And you can take a second to think about this. If we try to do what we've been doing, I would take 9 over 1. That's obviously 9. Then I could take 12 over 2. That is 6. And then 15 over 3. That's 5. Right? And the pattern continues. Well, I shouldn't say the pattern continues. What I mean is that I'm getting different numbers every time. That's different from what happened before. Before we got the same number every time. That's one of the reasons we could tell it was proportional. So because I'm getting different numbers, I could tell it's non-proportional. I can also, if I go backwards here like we were doing, so the x row still is 1, 2, 3, 4, so I'm still going to need a 0 here so that it says 0, 1, 2, 3, 4. The y's goes 9, 12, 15, 18. Think of your common difference there. Looks like they're adding 3. So if I want to go backwards from 9, I have to subtract 3. That gives me 6. Now 6 plus 3 is 9. 9 plus 3 is 12. And that makes sense, but that's not the origin. That's the point 0, 6. So again, I can tell that that's not proportional because it did not pass through 0, 0. I do see 0, 6 on my graph. It's right there. And we should know from previous lessons that that point, 0, 6, is our y-intercept. That's where our line crosses our y-axis, right? So there it is. Now, what they wanted me to do is write an equation in function notation for the graph. All right. Let me just take a peek at something here. Okay, it didn't help me out too much. But yeah, all right. Function notation. I just want to make sure we should be using f of x. I don't want to confuse you on that, but function notation is f of x. F of x and y mean the exact same thing. All right, so we're still thinking the same type of thing. Now, we're still going to use our rate of change, our same rate of change. And in order to do that, we're really looking to see, and this goes back to some things that we've done before, we're looking to see how much do these go up by every time. So we said that's plus 3, plus 3, plus 3. How much do my x's go up every time? Plus 1, plus 1, plus 1. To find rate of change, I'm taking the changes divided by one another. So that would be 3 over 1, which is 3. So what's going to happen here is this is kind of similar to y equals kx. Now y equals kx we're saying is for proportional. We're saying that this is non-proportional. But if you follow me for a second here, the k value is still kind of similar because that's your rate of change and that's that 3. So we're still going to put a 3 in place of k. We're still going to put an x next to it. But now we have to account for the fact that it doesn't go through the origin. So where does it go through? It goes through 0, 6. That's 6 above the origin. So we're going to do plus 6. That's the equation that we want. And then I'm just going to bring it. Whoops, my pen slipped there. I'm going to bring it up to here so we could do it in function notation. And like I said, the only difference is that y is going to become f of x. The rest is not going to change. So this is going to say 3x plus 6. That is the equation for this particular function. All right. Getting a little lengthy here on the video. That's all right. All right, write an equation in function notation for the relation shown in this table. So, I don't know. The first thing I'm going to do is I'm going to see what our first point is. Does it go through the origin? X row goes 1, 2, 3, 4, so I need a 0. Y goes 3, 2, 1, 0. So this would have to be a 4. 4, 3, 2, 1, 0. That makes sense. You're subtracting 1 every time. So it does not go through the origin. It goes through 0, 4. That's my y-intercept. That's 4 above the origin. So when I write my equation in f of x, I'm going to need something here. But then I'm also going to add 4 to account for the fact that we're crossing the y-axis 4 above the origin. What is my rate of change? So let's find that out. These are going up by 1 every time, plus 1, plus 1, plus 1. These are going down by 1 every time, minus 1, minus 1, minus 1. So change in y is -1, change in x is +1. That's -1. So we're going to have -1x plus 4. That's my equation for that one. And then for this one, maybe we could do it a little bit more quickly. I'm going to do f of x equals, I'll figure out this part in a second, but what should I have? I'm not going through the origin. I don't see the origin on this one. Where do we go? We're going through the y-axis here. There's our y-intercept. And that is 1, 2, 3, 4. That's 0, -4. That's 4 below the origin. So we're going to have a -4 at the end of this. And then in order to find my coefficient of x here, I need to look at rise over run. I'm going up 2. I'm running 1, up 2, over 1, up 2, over 1. Right? So that got a little sloppy, but up 2 over 1. And that looks like a positive slope if we think about Mr. Slope Guy. Up 2 over 1. 2 divided by 1 is really just 2. So I'm going to have 2x minus 4 for this one. So the number that gets added or subtracted at the end of your equation is just how far above or below the origin our line intersects the y-axis. And the number with the x is your rate of change, or we call it your slope. That's kind of what we're getting closer to is y equals mx plus b and graphing lines. All right, here's the wrap up. You should give this a head start because we're going to end up talking about it in class. We'd like to see some work on this, obviously. And other than that, you're just going to have to finish off the Delta Math assignment based on the stuff that's in there. All right, adios.